All right, everybody, thank you very much for being here. SAP Day 6, the AM session. Today is all about geospatial science, both the technology part of it and some information about the outreach that's happening in the state. So, folks that may already be having relationships with your schools and visiting and that kind of stuff. So the AM session, I'm going to start first, as I normally do. And remember, we've been talking a lot about urban heat island, measuring the urban heat island over time. And then yesterday, we talked a lot about starting to measure the additional variables that really explain how that problem is distributed. And then we brought in environmental equity kind of as a framework to be able to think about all the problems, especially the ones that have to do with pollution and things in the environment that make people sick, like landfills, power generation equipment, freeways, and that kind of stuff. So today we're going to focus more and more on the tools. So if you choose to run with that environmental monitoring project yesterday, today's really an extension of how that would look. And today you're going to see more examples both in how we peer into the land and some additional uh, data that we can use to explain why farmland is different over time or why the vegetation changes over time. Uh, so we'll cover more on that. And then right around 11, we have two professionals from the industry, Dr. Jill Brown and Miss Grace Harmon. They're both with Kentucky Geographic Alliance, and that is I guess, an advocacy group that works with teachers and schools to create programs that can do very much what we're trying to do here and introduce this problem solving and this skill development, but within the context that makes sense for you at your high school. So they're going to share probably some experiences about their work with individual schools, and what we hope to do is now that we've met you through the program, and if we get you interested in doing this type of work, well, I will next follow up with the folks at your school. Maybe there's a teacher at your place that is interested in this type of work and can help us think through about how we can make it make sense for you to do this kind of work, but still be getting your own schoolwork done. So, projects at your school, taking the drone to the school, setting up weather equipment at the school, and doing kind of citizen scientist stuff. Just to give more and more opportunity for everybody to get involved with this kind of work. And then in the afternoon's a little different. Both of our presenters had to be away today before the scheduled day came, so they pre-recorded the information they have. Ariel Weaver is a GIS remote sensing analyst that I used to go to school with at University of Louisville, and basically since graduation, she has been doing all kinds of amazing things in geography. So using GIS and remote sensing tools, but going to all kinds of amazing places all over the world and working and helping people in these regions. So here today, she's going to be talking about some of the countries that make up Southern Africa, and they're looking at how this huge savanna grassland that floods every year, how this is changing over time, and how the people and the animals and everything is responding to that within the context of something like climate change, but really just thinking about long-term changes in temperature, precipitation, and then the land, responds to that and adjust. And then Demetrio Zarakis, a legend in the remote sensing community, he has pre-recorded some interviews with other professionals. Scott Dobler, who's also connected to KGA and at Western Kentucky University, he's got a long history in working for like governmental and private institutions doing GIS work, and he's also very generous with his time in working with community groups and education groups, again, to try to create opportunities for young people and educators to get involved with this kind of work. and he has Charlie Fitzpatrick, who is with Esri. And we won't talk about it much today, but Esri is really the king in the geospatial in terms of software. So ESRI is to geospatial what Microsoft is to the Office. Okay, so everything you need to do in GIS, every product, ESRI has a division of folks. It's a huge company in California. It's a huge technology company, and there's tons of opportunities. So if you like this kind of work, there's hopefully they're going to do a good job of just painting a picture of what all's out there. All right, any questions about what we're going to cover today, or anybody have a comment? All right, well, we will go ahead and get started. And I'll just mention, as always, that everything we do is to help people out, to create opportunities for people, and to help people solve problems, to help young people learn skills so that they can do very interesting work and have prosperous, careers. So this presentation that I'm going to get through here in about, see how much time we have, about 35 minutes. I'm going to briefly introduce GIS remote sensing. You've been seeing bits and pieces of it already, and we're just going to kind of reaffirm what we already know about it, a quick review, and just say a few more things about it. And then we're going to look at kind of two branches of the work that we do here at KSU, in particular, monitoring of the environment, meaning basically the land surface. So that could be managed land areas or agricultural land. And, oh, excuse me. And we're going to look at the monitoring of both the weather and the climate, okay? Because the environment, the surface of the earth, is basically our proximate starting point, right? It dictates a lot of what is even possible to happen at a place. You can only do so much development or so much farmland. Let me check the chat real quick. Doing citizen science stuff. Yes, okay, that's I'll try to define that a little bit better, but that's kind of just the broadest term. And it just means that young people who are not trained and are not obligated are still getting involved with the work that's going on. Okay, so there are scientists and researchers and government people who are making all kinds of decisions for how we're going to live our lives. A lot of this you hear playing out in the unrest and the political fighting and the polarization and social media fighting. It you know, choose which problems you want to work on. How you want to make the world a better place, and just get focused on that. The sooner the better. And if geospatial technology, if the tools are useful for helping you tell your story and for counting and measuring the aspects of your problem, that's how you formulate a basis of knowledge, and that's what you have to be able to move forward to solve any kind of problem. So we're going to look at the kinds of problems that we do here at KSU in our research area. So just to remind, geographic information systems is really, it's an umbrella that includes both computer technology, the trained analyst, all the kinds of data that you could find, all kinds of algorithms. All this technology in a huge bucket is collectively known as geographic information systems, right? So systems meaning there's many parts and they operate together to function as the whole, all right? And in GIS, it looks like mapping. It's just mapping. But all the physical phenomenon, all the social information, all of that can be represented in a GIS. It's a digital representation of the real world. And everything that needs to be represented in your model can be represented in this GIS. So here in the previous days, we talked about land cover, urban heat island, the heat magnitude distribution. We've looked at census data, all that stuff. Okay, and here in this little example, there's more. City boundaries, various parcel data, land use maps, okay, and then topographic data like elevation and biomass and just all these things. And at the bottom here, you see we have a digital representation. So when you start doing modeling and forecasting and all, and you know, this is what the computer's working with, is this little abstract version of the real world, okay? And in general, geography, that's kind of what we do. That's our business, is characterizing the space, right? In both the physical and the social way. Connected to that is this idea of remote sensing. And remote sensing is really what I spend a lot of my time doing. And we've been talking a lot about what remote sensing is. Okay, your eyeballs are remote sensors, right? Sunlight comes from the sun and reflects off the earth, and your eyes receive that light, and that's how you see what's around you. Okay, the satellites basically are working the same way, but instead of eyeballs, there's what do they call them? Charged coupled devices. They're basically little sensors that just measure the light that comes in them. Basically, like the rods and cones in your eyeballs are working. There's a digital sensor analogy to that. Okay, and the visible light is the energy coming from the sun, and that's what you see, and that's what plants are using for photosynthesis, right? And when we're looking at the urban heat island, we're actually looking at energy that's way over here to the right, off of the map even. That is the long wave infrared that's re-emitted from the Earth, right? So the Earth basically is absorbing the visible light and then re-emitting long wave radiation. What you know as the heat that's rising up from the pavement or whatever. And all of this technology started to come to us World War II, post World War One kind of area. So it was a necessity as the military went into new places. You rapidly need to know everything about the place, the physical characteristics, the elevation, what the climate and the weather is like. And unfortunately, in the past, it was just about war and gaining the advantage. So before the military can go, you know, all the people can go in there, they need to know all the conditions. So this is kind of where the mapping stuff was born. At this same time, you know, they're getting ready. They're beginning to do space flight and stuff, right? So the monitoring of the weather and being able to predict what the patterns are going to look like coming up very soon becomes very, very important. And I don't have time to talk about it today, but there's this very rich history and just these incredible stories about how all of this was born. And I just want to note that I've said constantly through all of our meetings that we're funded by the National Science Foundation and the USDA, and these are taxpayer dollars, right? And part of the reason they do this is just because of the importance of it. And most of these government agencies that we've been referring to, the USGS, NOAA, all these agencies that are tasked with running the satellites and collecting the data and creating ways to share it, all of this stuff falls under the Commerce Cabinet in the U.S. government. Okay, so it's about advantage, right? It's about knowledge and advantage, and it's as big today as it's ever been. And all of the stuff, you know, well, not all of it, a very famous bowl of all of this beginning stuff was the Tuskegee Airmen and all the places connected to that. And I don't know enough about it to share, but there's very interesting stuff. So if you have any historical interest, you know, this is a very great story to look into. And as it progressed, okay, they get better at it. And the earliest climate models, you know, they're very similar still to how our understanding is. So I don't know if you can see this real good in here, but this is from the 1960s. This is one of the first climate models made, okay, very first simulations. This was the very beginning of figuring out how pressure and temperature and moisture was distributed around the earth in a very predictable way. How predictable? How predictable are the seasons, right? Winter always comes on time. Summer always comes on time. So there's a certain pattern to this that sets up, and that's really what we think about as kind of the long-term climate, right? But how exactly these little bubbles perturbate here or there, one can't really be sure. And that starts to lend to how hard it is to predict what the weather is. The weather is what's happening at any one point in time. Okay, so this isn't super detailed, but that's the North Pole there in the center, and this is a global circulation model showing how all that stuff is transported around the earth. And today, what that's really all led into with hundreds of satellites, maybe thousands of satellites at any given time, and tons of ground data. And as I mentioned before, we essentially are watching a movie of all that has taken place on Earth. Um, I mean, not only do we literally have satellites that just have cameras, right, that are just making a movie of the Earth, but all these sensors that we're talking about that are sensitive to these different parts of energy that can very finely resolve small differences in moisture content or temperature, or the most broadest things like just watching the polar ice caps melt during the summer. Okay, so when we talk about long-term change, the climate, okay, there is no question really about what is happening, okay? The what of what's happening, okay? The seas are rising. The ice is clearly melting. Stuff is getting hotter. The northern, the northern latitudes are getting super hot, right? Some places are getting cooler, but the vast majority, okay, it's very clear to see. So there's really not a debate in terms of what's happening from this point in time to that point in time. That's really the easy part. And what we do in the geospatial area is we use this information, okay, to understand our world, but do it on behalf of the farmers and the land managers in the state of Kentucky. So we're always talking about extension and what extension does. Well, they work with farmers. They work with land managers that are, trying to produce income from the natural resources that we have. And the whole point of looking at long-term climate change is only to understand how it's going to impact the farm at the local scale. Okay, so here's another key point about here's the global scale, and everybody on Earth is subject to this one finitely small system. Okay, but any one spot on the Earth, is going to have a different outcome. Okay, a different outcome. So change over time looks different to you than it does to me because our setups are different, right? We're just doing different things. I'm going to go ahead and mute everybody. If you could just make sure that you're muted. This example here is just one from Shelby County, right outside of Louisville, where you guys are. And it's just a snapshot on the right-hand side. So before I ever go out to a farm or to an area, I already know a lot about what's going on. I've already pulled a lot of the satellite data. Down here in the bottom left, this is a summer day showing me the distribution of vegetation productivity, right? Here are the darker green areas, that's highly photosynthetic activity, and the lighter areas, it's a little less, right? And over time, I've tracked this for the last 20 years. So we can get one measurement a week over the whole course of, say, 20 years. And we can see how productive the land has been each year, right? We can see the high years, we can see these couple of really terrible years, and that was probably due to drought, right? Or just less rain than was expected. And then we have this other data here derived from the LIDAR data sets that shows us exactly the topographic characteristic of the farm. And we can extract from that all the things that are on the land, including the trees and the bushes, so we can measure precisely just how much vegetation stuff is on a particular farm and how that's changed, right? So, as professionals, before we go out to a place, we already have a good idea of what to expect about a particular land before we get out there. Okay. And then further, uh, a lot of time people are just interested. They want this own kind of data for their own land. So we work a lot too. We don't always have to go out there and do all the work. We hold little workshops to help people help themselves kind of get with it. Okay. And a lot of times people already have it together, and they're just trying to push the boundary of what's possible. Uh, but anyway, here on the left, a quick image that just shows all the different ways the drone can see. Okay, so the drone has different sensors that's sensitive to all different wavelengths of light. We won't cover the particular wavelengths, but they're just all chosen because they're particularly useful for looking at aspects of vegetation. And how does that work? Okay, it's really simple. You remember that all the sunlight coming from the sun, okay, we can call it either red, green, or blue, and all colors are made from red, green, or blue in some mixture. As this image shows here, as on the left-hand side, as the visible red, green, and blue light comes into the plant, the red and the blue are absorbed because that's the energy the plant likes for photosynthesis. The green is then available to be reflected out. So that's what your eyes see because that's what's left, right? NDVI is a simple little fraction that just looks at the relative difference between how much visible energy is retained by the plant relative to how much infrared is reflected out, near infrared is reflected out of the plant. Simple fraction. The math part doesn't even matter, but the idea is that the larger the difference between the two, the healthier the plant. And your eyes see this as nice green plants, right? Because of what's happening in this picture. In the wintertime or during a drought, or when you spray poison on a plant, what happens to it? It starts to turn brown, right? And why does it turn brown? Because if you start to mix purple and green, you will get brown, right? Why purple? Because blue and red, if you mix them finger paints together, you get purple, right? So what does that say? That says when those two wavelengths of light are equally reflected, your eye, it appears purple, okay? And just as an experiment, that's how you can kind of prove what's happening. So it works in principle with finger paint, and kind of the same thing is happening here with the plant. And that's why it's so useful and so universally accepted, because it's very easy to understand. That's why we use it. And what it allows us to do is compare basically apples to apples in a relative sense. How much photosynthesis is this plant doing? Now, that's not enough energy to know if it's good or bad. Okay. We don't know if it's good or bad, but we know what the value is. The expert who is familiar with the plant would be the one to say if it's, good or bad. All right, and this little image here on the right, this is just a zoomed in. So for you folks that are building the raised garden beds, okay, you're going to build the raised garden beds, and you're going to put a great variety of stuff in there, okay? When I view that with my sophisticated NDVI sensor, look here in each of these little box plots. I can see the distribution of the type of crops you have, okay? So you see kind of each different color of blob kind of in here is like a little grouping of a particular species. So I see clearly one species, two species, three species, four, same as that one, a fifth species, right? And then further, so say right here, this is all the same crop right here, right? Within that, I can see the variation of the photosynthetically active parts of the plant. And it'll change as the plant grows, right? Because a leaf, the whole thing is doing photosynthesis. But on crops, as the plant matures, it starts to develop lots of plants or plant parts that don't do photosynthesis. They do other stuff like a corn tassel or I don't know, just different petals of the flower for just different parts of the plant that are not engaged in photosynthesis, and therefore it wouldn't read. Okay, like here, this is a very low intensity crop here. It's not doing a ton of photosynthesis. All right, I see some variation in there. We don't know if that's good or bad. It would depend on the crop and how what the management's happening here. But our part of it is the recording and the documentation of what we see. And then once we label it, okay, that's really where we get to then what we call machine learning, where the computers essentially learn from the labels that we give it. Okay, that's kind of the AI approach to identifying uh, everything basically from images, including faces. So the math behind this stuff, like an artificial face recognition system, is very much the same math that's used behind, classifying very healthy crops versus not healthy crops. Okay, it's all in the math. It's all in the math. So how do we take advantage of this? Well, we have a fleet of drones. We have a bunch of drones, small drones and big drones. We have some drones that are large enough to carry small children around. Uh, as a potential project, okay, if no projects that I've offered thus far work, we could do something else. We could go out some natural area and map it out with the drone, and then we could spend the next few days processing. Okay, here on the left, this is a type of image that's taken with the sensor, and what that allows us to do then is do that NDVI trick and be able to map out uh, the trajectory of the land cover. So if we're doing it say once a week or once a month, we're able to measure then for each of the various plots how productive they are over time, and that can translate directly into yield. So this information here, how green it looks in the image, you could calculate pretty precisely how much corn kernel you could expect or something, right? Once you have a model established. And we use the satellite data and do this on a much larger scale as well. This is actually Sentinel-3 data. It's something like 10 meters, and the revisit time is like 3 days. So this is essentially a game changer for everything that came before it. And new Sentinel satellites are planned several a year from now and to forever. All right, so I'll just pause right there for 1 second and just give anybody the opportunity to ask about the kind of GIS or remote sensing part of it. Uh, these few concepts and topics that I just covered, all the urban heat island stuff that we've been talking about the last couple of days fits exactly within there. That's the technology that's used, and that's what we've been doing. And that allows us to see the land as it is today, right? And then because we've had satellites looking over the last 30 or 40 years, we're also able to know how the land has been changing over time. All right. So that's kind of that part of it. Now this kind of last part of my agenda has to do with the climate and the weather and the monitoring of that. And so the land is what it is. It has a certain soil. It's a function of its geologic history. Okay. The whole 4 billion years that the earth has been doing its thing has led up to whatever your backyard you have, that's what you have. And that area, the universe is responsible for that. From there, the farmer can manage the land, and he can add or she can add chemicals or add stuff to take away chemicals. And that's the bulk of the management strategy. On top of that, you have something that certainly cannot be controlled, and that's the climate. So the climate, in some ways, is supposed to be pretty stable, at least over the decadal sense. So when we talk about climate normals, we're talking about the mean condition for the last 30 years. So I think right now, currently, we're in the 1990 to 2020 climate normal. So when you hear them talk about right now where, our precipitation is 30% above normal. That means over the 30 years for this date all the time, here's the probability that it's going to rain. This year, it's certainly more likely every day that it's going to rain compared to what the climate normal says. And as we're going to look at just here in a second, that's actually one indication of global climate change are the changing precipitation patterns. So the distinction then to be made between the climate and the weather is just time, right? Just time. So a snapshot of the weather is the temperature, humidity, precipitation, the wind, whatever the conditions are right now. Do I need to wear a jacket? Do I need to wear, double socks? What needs to happen? That's the weather. The climate, like I said, is the longer term average. And when we start talking about change over time, we're always talking about the climate because the weather is expected to change all the time. That's why it's called the weather. Okay. And in this presentation, I've actually shared is somebody writing on the screen? Yeah.
That's,
Okay.
but I don't know how to stop it.
That's okay. I thought I was tripping for a second because I saw it. I said,
I'm
how did
sorry.
I even do that? And then it happened again. I was like, oh man. All right, all right. So
And I
that's no
thought it was only
problem.
on my
I
screen.
don't
I'm
know. I
trying
don't
to
know how to fix it
highlight
either, but
something.
it's all right.
Okay.
Yeah, no worries, no worries. All right. So also kind of embedded in this conversation here is severe weather. All right. And what is severe weather? Well, you know it when you see it. Okay. You know it when you see it. Oh, let me go back to that because it ruins your day. Right. It ruins the day and it breaks stuff. Okay. And sometimes it kills people, and we're in the midst of hurricane season right now. So ripping up, right across the west coast of Florida is a very small hurricane, thankfully. But they say the conditions are just right this summer that some big ones are, possibly going to come out. And hurricanes don't travel along, right? They bring heavy, heavy precipitation, and flood is like the number one killer in terms of the weather killing people. Floods are deadly. Turn around, don't drown. That's for real because floods kill uh, more than anything else, and they damage more stuff more than anything else too. And of course, hurricanes bring wind, and they also spawn tornadoes. So the big threat actually in Florida today is less the wind itself, but it's actually the threat of flood and tornadoes. Okay, flood and tornadoes. And these have happened over time, and you can probably think of a lot of really big, scary examples. Supposed to be another historic fire season again in the West, right? And it's droughter than it's drier than it's ever been. The temperatures are slowly creeping up for sure. And the winds are just incredible out there. This phenomenon known as the Santa Ana winds, and it's just 60 miles an hour all the time. It's like a blow dryer. Okay, just hot, hot, dry air going down the valleys. And when something starts, it's hard to put it out. Earlier this year, we had flooding all over the place in the South, Mississippi River Basin. We had multiple towns in East Kentucky completely flood out. Beattyville, half the town was underwater. The Kentucky River, the northern end of it, and all the tributaries that feed into that, they're small and flat, and just so much rain was falling over the course of a few days, and it just filled up. If anybody follows international news, all over Eastern China, the rain has just been unreal. There's just everywhere is flooding. Okay, and flooding is one of the most important components of climate change in general. Uh, the threat of flood, and seemingly paradoxically, the threat of drought. Okay, the threat of drought. So when the rain comes, it's all coming at once, and then the tap turns off, and it doesn't come back until a flood comes back. That's really hard on crops. It's really hard on land managers. Okay, so that's again, that's a reason that we look at it. And let me real quick just disable the waiting room. Okay. Yeah. All right. And so, and why is it such a taxpayer interest? In addition to us serving farmers and serving land managers and creating opportunities for students to just learn skills, why else is it very important? Well, because of the cost of the disasters. So here's a map showing just last year the top 20 billion-dollar disasters. Okay, and these little icons show you kind of what they were. So lots of hurricanes, lots of thunderstorm and rainfall, big hail in Iowa and big wind with that. Of course, drought. Of course, fire. You remember an entire town called Paradise burnt completely to the ground last year or the year before that. So things like that just continue to happen, and because of insurance and because of payments by agencies such as FEMA, the cost to the taxpayer is just very huge, very huge. And here's a chart that basically has that same point data, but has it for all these years between 1980 and 2020. And on the y-axis here on the left side, it's the number of events, okay? And that's how tall the bar is. It's how many billion-dollar disasters there were. And what trend do you see since 1980 to 2020? Do you see a pattern is the question. I'm pretty sure I see one that looks like a little bit of increase, if nothing else. Okay. And then the way the bars are colored up here, this legend shows you which type of severe weather event it was. All right. So you can see also in that same data that severe storm, okay, has grown tremendously. But there's kind of two things going on here. So remember, this is in cost, okay? So we're better at seeing storms, so we're naturally going to see more of them. There's more people in more places, so the opportunity to be negatively impacted by them is certainly gone up. And plus, everything's just getting more expensive as time goes on, as just natural inflation goes. So how big of a problem it is really in the eye of the beholder in terms of what it is that matters to you. Insurance, as we really know it, is kind of a private endeavor. But what if, when an insurance company pulls out of a state, after Hurricane Katrina, for example, then the taxpayers have to come back in because we have to have insurance to protect property, or we can't do business in the regular way. So that there's it's not as cut and dry as it might seem on the face of it. Okay, so the moral of that is that it impacts us all, and that's why it's important, and that's why we continue to get funding to both do the work, to think about how it works for farmers and land managers, and to create the opportunities where you can join in. Okay, where you can join in and learn the skills, and then if you wanted, you could get a job at these places. We've already introduced you to two people who have left our programs and went to work at places like this. DeAndre Garrison has worked at multiple places like this. So a quick note on the climate change. We only have just a couple of minutes. Uh, so we've kind of skirted around climate change a little bit, even though it's popped up a few times. But as I mentioned, because we have so much data and we've been watching so consistently over time, it's very clear what the last several decades have looked like. Okay, so air temperature measured at 2 meters has clearly risen a little bit. Okay, and the rate at which it's increasing seems to be getting faster. And certainly the last several years have seen countless records broken. And like Portland, Oregon just got out of like literally a temperature for the hottest temperature ever recorded in that place, never mind the day or the season. Okay, so things are happening, and it's clear to see them, and we have this data that's documenting them. And remember, we've been taking data since 1880. Okay, so let me draw your attention to the left-hand side chart. Imagine all these station data, all these weather stations all over the world. Okay, they've been measuring temperature since 1980. Stations come and go. They get moved, they get broke, they get replaced. Okay, so there's huge science effort to go and make these homogeneous long-term records. Okay, and it's all model. Okay, but the point of it, as this chart shows, is there are many different teams working with the available data, and they all have pretty good success in constructing what temperature has done. Okay, and here we're talking about the whole world, so mean temperature. The point here is that so each line belongs to each team's predictions. Okay, and there is some disagreement as far as where exactly on the y-axis it belongs, but the pattern, the noise is very clear, right? So, what do you see has happened there over the last 130 years that we have data for? Well, clearly temperatures have increased about 1.5 degrees, right? But that's the mean for the whole globe. In the North Pole sections, right, we're up to like 5 or 6 degrees for some seasons, right? And in mid-latitude places, in some cases like Kentucky, we were actually a little cooler. We're a little cooler over time. More rain and a little cooler. It's weird stuff. All right. So that's that. And then on the right hand side, this is the distribution of temperature for each month, right? So this is just showing you the distribution of temperatures for the whole year each year, right? So as the years continue to increase, what's happening to this line for all of the months? It's increasing, right? And that's really not an argument so much. That's just what the data shows. Okay. That's just what the data showed. Now we already talked about some of the problematic elements of having the weather system, because mostly the stations are where the people are, and there's the urban heat island, and that's complicating things, and all that's still true. Okay. But what do you see with your own eyeballs is your first indication of, do I see change or not? Okay. And this is from NASA. This is NASA data, and it was just I actually just found this on Twitter. A social media guy put this together. All right. So that's temperature, and that's mostly what you hear about. That's the connection. CO2 increases temperature, and mostly in terms of climate change, you hear about the temperature. But perhaps more important for us in terms of agriculture and other land management is the precipitation rate, because photosynthesis does not happen without precipitation, no matter how good the soil is and no matter how good the farmer's management practices. If there's not enough precipitation, you do not get flour, food, nuts, whatever it is that you're trying to make. Over time, okay, precipitation rates are increasing, and particularly extreme single day events are increasing. All right, over time since 1980, it's raining just a little bit more in terms of the total per year, but it's raining fewer times. So more water is being delivered in a shorter amount of time. So it's flooding in some cases more than it's slowly percolating in to, quench the land's thirst. So that's an issue. Okay. And I have to mention space weather. Uh, this is certainly less understood. And here recently, this whole little part of science has just exploded. There's just all kinds of really cool papers coming out that are just really changing our understanding of Earth's place within the solar system. So as space kind of seems like it maybe wouldn't, I wasn't interested in space until recently, and I started kind of learning about what they're finding out here recently. But for our purposes here, and thinking about severe weather, as this image shows, now this is a pretty old image, and they have much better images now. NASA has all these satellites that are spread out through the solar system, and they're looking at different aspects of how the sun's energy is interacting with the different planets. And so you have the solar wind, and this is just this constant stream of particles that are just kind of glowing off of the sun, right? These are the particles that are always headed. And then periodically, you have these magnetic disturbances that basically explode or reconnect, and it ejects all of this plasma. All right, highly energetic particles, plasma. This is like the leftover nuclear waste essentially being blasted off the sun. And, if it comes right at us, all right, it will, thankfully, we have the magnetosphere that protects us from this. But even still, when that energy comes up against that, it creates all kind of electrical currents and stuff that do really crazy stuff to satellites. It just will wipe them out totally. All right, these coronal mass ejections can just, literally just like matter hitting something, kinetically destroy them. But even if not that, the electricity and the magnetic forces will do damage to our electronics. And there's even been cases where, for particular storms, they have these long electrical charges that go through all the pipelines and the long lines that are laid in the seas and all that are connected to, two big grounded terminals. So as the energy kind of passes through, electronic devices are impacted, to say the least. You may not know it, but all the time your GPS isn't working correctly. Sometimes when you're talking on the phone, the signal's actually being interrupted by this constant this, right? It's all the time, and it's every day. And thankfully there's a huge group of people, and this is all they look at all the time. And if you just kind of Google around, and the kind of the area is heliophysics. Okay, so if you're kind of interested in this, there's a lot of cool space stuff out there, and there's all kind of GIS, remote sensing data for all the individual planets. And apparently there's lots of stuff happening on the planets. This stuff's happening. It's really cool time to be looking at that. So to tie it back, right, to tie all this kind of back to the proposed urban heat island environmental monitoring project. Okay, uh, as I've shared here, and we've constantly been talking about the last couple of days, we can map out the local area, or you can better understand kind of how the environment, the climate is changing long term, and then how that might be impacting the piece of land that we're interested in. And there's all kinds of places to get this data. Here, I mostly have storm prediction stuff being shown, but when we start looking at a particular place, one of the most useful things right away is to just understand what the record is there, right? So an underappreciated problem in agriculture is actually the damage that's done by severe weather. So wind can destroy crops, and it does every year. Hail destroys crops every year, and there's insurance that's connected to this. And right now, one of the kind of the big tech things happening is people bringing this free geospatial capacity to bear on things like uh, pricing insurance risk or monitoring the land to know when a potential claim has happened. So there's some really cool companies that just started recently from founders from Louisville that they are using AI to monitor these data sets and just compare it to a list of the customers. So, when something happens, the satellite see it, the data network sees it, and then this is made available to you on a portal. So you could have a program that's running that's constantly checking these databases and then knowing whenever it's close to one of your customers. Even if it's just that, is this dot close to my customer? There's some information in there, right? For the insurance company, because then they'll know, uh, if all this pink is where hailstorms happen, well, if that's your service area, then you're going to know that your customers were potentially impacted. And that's just one example. There could be infinite others, infinite others. Final note on the funders, as always, the two biggest grants here, National Science Foundation, and both of these are geared exactly toward creating opportunities for young people and people that work with young people to get involved. okay, either through skill development or through knowledge or through being able to learn and then work with professionals that are out there, including small farmers and land managers. And some references that I'll share a little bit later. So that was a lot of ground. That was a lot of ground that we covered. Any questions? Any questions about either the technology that we covered or any questions about um, the climate aspects of it, or question about how that fits within the urban heat island project that we've been talking about? That's okay. If you do have questions, you can put them in the chat. You can send them to me directly, or we'll continue to make time. Uh, all right. Well, we'll say that's the end of that section. I see Miss Brown got on, Dr. Brown. So let's see. Let's just double check the schedule real quick. Yeah. All right. So Miss Brown, do we have you and Miss Grace Herman? We do. So we'll just move into the next part of it. Um, and I guess you guys really can just come on and introduce yourself. As you all seen on the schedule today, you see the names and the professional titles and the places where they're from. So yeah, feel free to take it away, Miss Brown.
Okay. Hello, my name is Jill Brown. I teach geography and environmental science at Western Kentucky University, and I am the state coordinator for the Kentucky Geographic Alliance. I have with me today one of my practicum students. Her name is Grace Herman, and she will be a senior this year and working on some projects, some with GIS and some for her honors. We have a overview of what the KGA is about, and we are going to share with you some of the resources that we have, and we're going to just share through our website, and we're going to do kind of a question and answer type of thing between the two of us. So Grace, do you want to take a moment to introduce yourself?
Hello, as she said, I'm a senior at WKU and a KGA practicum student. I'm a geography major with a focus in environmental science and then a certificate in GIS and emergency science and disaster management.
All right. So I did kind of tell you a little bit about the KGA, but I just want to let you know we are a nonprofit organization. We used to have a grant through National Geographic, which we no longer have. They changed. Disney now owns them and they no longer have the grants. So in order to keep the Kentucky Geographic Alliance going, I decided to create a practicum where students work for the Kentucky Geographic Alliance. So most of the things that we have on our website are our KGA training modules are done by students, and the students earn credit for that. Traditionally in the past, the KGA has mostly worked with educators from different school systems, just people that were interested in our resources. Now that we are involved with the Esri's ArcGIS online competition for middle and high schools, we now are starting to work more directly with students. All of our resources are free. They are put together by us or gathered from other resources, other places that we can share. Like I said, most of the stuff is done by the students.
So what sort of resources does the KGA have for students, teachers, and schools that want to get started with GIS?
Okay. I am going to share a couple things. Am I able to share my screen? Yeah. Okay, I'm going to share my screen and show you a couple things. Let's see here. Okay, so this is what our website looks like. And if you go to our menu, We actually have a variety of things that we use. We have teacher resources. These are for anything from elementary, middle, or high school. We do have a story map gallery that has a variety of different story maps from different disciplines. But this is probably one of the ones that is most helpful for people that want to get started with GIS. This is GIS in the classroom. And we have a link here to get the Esri license. Now, in order for a school to get the Esri license, you do have to have an interested teacher that is willing to sign up for that. And we have a link right to the website. And you can go in there, and the teacher does have to do this. I will show you. It is this one, ArcGIS for Schools bundle. So if anyone is interested in working with ArcGIS, but they don't have access to the software themselves, it can be what's the word I'm looking for? It can be acquired through Esri, but a teacher, an educator of some sort has to put in the request. If you don't have a geography teacher, I recommend going to school librarian or a media specialist, because they would be the ones that would have the most use for it throughout the school. So it wouldn't be just in one classroom. So that is one thing that we have. Other things that we have is we have Esri, we have links to Esri resources, other resources. We have KGA GIS tutorials, and those teach about geography concepts that are important for GIS. And then we also have data sources. Not Grace, but one of my other students told me that she thought one of the most challenging things about GIS was finding the right data for her project. And so Grace has taken it up on herself to start a page on our website that has a lot of data sources, and anybody can go in and use those. And she'll probably talk a little bit more in depth about that in a few minutes.
So can you give examples of some student projects in your classes and in the KGA that have allowed students to apply existing skills and learn new skills as they got started using GIS?
Yes. In general, and I heard this from a history teacher told me once that she always expects her students to put maps in their papers and projects. She said she was surprised at the number of people that don't include that when they're talking about places. So even if you're working on a project for a class that's not GIS, I think it's always good to use a map or have a map if you're talking about something spatial. In my classes, in my gen ed classes at the college level, whenever I have a paper or project, most of my classes are gen ed, but I do have students that are majors that have GIS. I offer my students to do a paper, a presentation, or a GIS project. I also teach a senior seminar class. That's a class for majors, and they have to do a class project in which they all work together on that. Grace, do you have any examples of projects that you have worked on?
I did a flood outlook project where I looked at flood outlooks for the state of Kentucky over a week when we had all that rain and flooding earlier this year. So I looked at the outlook. I looked at the outlooks for each of the day and how it changed and evolved over that week. And then I also added examples and photos of the flooding that actually occurred. So you can see the outlook, and then you can see what actually happened over that week.
Yeah, so this is an example of a story map that Grace had worked on. Okay. This thing the little menu keeps getting in my way when I want to click on something. There, I gotta move it, I guess. Stop getting in my way. It's not letting me move it, I'm sorry. I'm having technical difficulties. Okay. The other thing that we wanted to talk about was how interdisciplinary GIS is. It does not have to be used in a geography class. Like I said, I teach in geography and environmental science. I do not have GIS skills, which is the reason that I have students work for me. I took a GIS class a long time ago, about 20 years ago, and didn't really follow up and pursue that. I realize now that GIS is really important in geography. that you do need some of those GIS skills to get a job in geography. And GIS tends to be the highest paying job in geography. But there are a variety of ways that you can use GIS in different disciplines. So this is our story map gallery. It has a variety of story maps in it. You can see we have some, you can either click on them or scroll through them. We have environmental ones, human cultural. There's a lot of population type of story maps. There's education ones, political, geology, and our department includes a lot of weather. We have meteorologists in our department and a lot of meteorology students. So we're able to access some weather and climate type of story maps as well. So anybody that's interested in working on a story map, this would be a good place to go to see some of the different applications and the different types of story maps that we have. I came to campus, my lights just went off. There we go. I have to wave my arms and have motion for my lights to come back on. Okay.
Before we continue, can you talk a little bit about what Esri is?
Esri is a company that produces or makes the GIS software. They offer the free online one that they have for schools is all online. You don't have to have the programs downloaded onto your computer. So they offer that to schools for free, this online bundle. If you really get into GIS, you probably have to have the software or the programs directly on your computer, and that would take more memory. My son took his first GIS class this past spring, and he had an older laptop, and he couldn't get all the things he needed for that GIS class, and he just had to buy some extra memory for that. Esri also funds some of the things we do for GIS. So we do have a little bit of funding for GIS activities in education. So we do have a little bit of funding for that. And that allows us to go to conferences and go to schools if we need to, if a school needs us to come and do in-person training. Okay, so I am going to stop sharing my screen, and then I'm going to ask Grace some questions and let her share her screen if she needs to. Okay, so I already talked about my senior seminar class, and that was collaborative. And Grace, do you have any other projects that you've worked on that were collaborative with other students, or things that you could share that you found that were group projects for GIS?
So I have worked on a couple of group projects for GIS. I don't have this one to show, but for one of my classes, we worked on a project where we looked at nitrogen runoff. So we looked at all the different water basins and how the stormwater would move in order to relate that to the dead zones in the Gulf of Mexico. We also did another project where we looked at all the Bob Evans locations within Kentucky, and then we had to come up with criteria based on population, income, roads, transportation, and all other sorts of information in order to decide where we thought a new Bob Evans location would go. So we've done all sorts of things like that. I also have some examples of group projects from the National ArcGIS online competition for middle schoolers and high schoolers. So that is a project, that's a competition here where students create their own projects based on their communities, so they can look at anything they want as long as it's through their community. And then they can submit it to first the state, which we run the state office for this project. And then from the state, several of them will go to the national level to compete. So some of the ones from 2020, one was a group looked at food deserts in Murfreesboro, Tennessee. So they looked at the different factors and then different solutions for their local food insecurities. Another one was in Massachusetts where they looked at turtle conservation. So they looked at the area, the endangered turtles in their region, and then they found the areas where habitat would be best for them. And then they looked at which of those areas would be protected and which may need to be protected to be best. So there's all sorts of different projects that you can do with GIS as groups. If you can think of something geographical, you can do a project on it.
Okay, that sounds good. There's a lot of variety in there. So students could do a project on anything that they find in their community that could be mapped basically for this competition. Okay, we do have an interactive question for any students that want to participate. You could, if you are in a room with other students, you could chat with them about it, or if you are online, you can just put your ideas in the chat. But we thought we would ask the participants to think about some ideas that they could map in their community, any sort of problem that might be in their community that they have observed as a person in the community. Some examples are, do you carry a reusable water bottle but have a hard time finding a place to fill it? We all know that has changed with COVID. It's harder to find a place to fill your water bottle. Another problem could be that you play a sport in your neighborhood, but you don't have enough green space, and the green space might be too far away, but there might be some empty lots near you that could be green space. Another thing is there enough access to public bathrooms? If you're outside doing stuff with your friends, but you're not at a business, do you have places to use the bathroom? And other things like, does your route to school make sense? Or does the pickup line at your school get too weighed down? So we just wanted everybody to take a minute to think about some things that they might be able to map out in their community to solve a problem. So I just want to give people a few minutes to talk about that or come up with some ideas and put them in the chat.
Yeah, feel free to unmute yourself and blurt out any good ideas you have. Some of our groups, they are working on producing food and stuff at their locations and thinking about how to distribute it around their little area. So that's one potential idea. They have farmland, small farmland that they're developing. They could try to keep track of that. Any other ideas that you all may have? Pothole reporting system. I've seen that a few times. I think there's one thing in the chat looking at agricultural food distributions. And we've been talking a lot about urban heat island, and we did a hands-on activity the other day where they, as part of the GLOBE, the NASA GLOBE project, they went out and recorded land cover and thermal infrared temperatures and then mapped those out in a story map kind of format.
That sounds great. Another good idea that I saw I would love to pursue here where we have caves and karst. I saw in Western New York, I'm from south of Buffalo, New York, up in the snow belt, but I saw that they had monitoring stations, and it was crowdsourcing data where they had set up measurements for streams. And when you hiked, when you got to the measurement, you would just type in what the measurement was at when you were there. And they crowdsourced data that way. So it was all collected and they had all the different spots. So as long as you had your GIS on, they knew which spot you were at. So that was pretty neat. I like the food system idea because we do have some food deserts in some of our towns. One of the things our town has done here in Bowling Green is we have one of our farmers market has a mobile bus that goes, and it's kind of like a bookmobile, but it's a food mobile and it stops at different places where there are not grocery stores. Okay, Grace, do you want to talk a little bit about the technology background that students, what type of technology background students need in order to get started with GIS, and maybe touch on what technology background you had before you got interested in GIS?
I really had no technology background. I did not consider myself good with computers. That was not really where my interests lie. You don't really need one to get started. There's organizations such as Esri and then the KGA actually. Sorry. Sorry. This one is also.
I know the menu's right up there.
Yeah, the KGA, and we have our own resources and tutorials for people to use to explore with and learn more about the technology aspect of it. There's all sorts of lessons on Esri's website, depending on what you want to work on specifically. If you do take a class, a lot of them will have textbooks, but they'll also have online learning opportunities. So you can sign in once you have that account, and it'll give you all sorts of information on how to continue going. There are YouTube videos for people who want that. You can find step-by-step instructions. There's a lot of different ways to learn as you go. You don't really need a background. I will say that if you have some Python knowledge, you can do some really cool things doing Python within GIS.
Oh, I saw in the chat about having students create a map that shows favorite shops and eateries. That would be a neat thing for people that travel with kids. If the students worked on their favorite places to eat, then they could maybe post that somewhere, and then people that come to your area that travel with middle school and high school kids would know the best places to go, because that's always a challenge for parents with kids, where to go. Parents want to go different places than the kids. So that idea looks like it would be a good travel blog. The other thing that Grace, the other thing that I have some issues with in classes when I'm trying to do technology things is all of the students have different devices. I have some students that bring laptops. I have some students that bring iPads or tablets. I have some students that try to do everything on their phone, even if my instructions say you should use a laptop. Which type of devices are best for building the story maps and or viewing the story maps?
So for building the story maps, it is best to use a laptop or a desktop. It's easiest to see the criteria and all the different options there, and to make sure everything's where it needs to be. That's also how most people view story maps. There are apps that you can download to look at story maps, or dashboards, or things along those lines on your phone. And there's also apps that you can download to help you gather GIS information or geospatial information on your phone. But when you're making the actual maps, it is best to do it on a laptop or a desktop.
Yeah, it actually looks like we may have lost Dr. Brown.
Okay, she's back. Sorry, we've been having technical difficulties and Wi-Fi issues all morning on both sides.
Yeah, sorry about that.
I apologize. I came to campus to get a really good connection because I live way out in the country, and I'm using the campus computer and it just turned off for no reason. I was using it and using the mouse. I don't know. Sorry about that. I'm back. Okay. All right. I'm back on my other computer, so. Okay. I lost my questions, Grace. I'm sorry. I can get on another computer and now I don't have them. So I think the next question was about data. We're going to talk a little bit about data because we just talked about the devices. So do you want to share with the participants the data that you put together, your data page and all of the different data that you have collected, and talk a little bit about different types of data. You might want to tell them about the difference between using your own data, examples of when you might use your own data versus when you would use somebody else's data.
Okay. So as she said, this is the data page that I have so far. It is far from complete. There is so much data that you can get out there. Everything that I put here is free data, because while you can get data through other areas, a lot of times you have to pay for it, but I'm trying to find free sources of data for people to use so that anyone can use it. So here I have two different types of data. So GIS data sources, which you can download, and it already comes in a space shape file or something that you can just put straight into your GIS, what you're using. I also found sources for data. So this data can be turned into GIS data through the use of Excel and then using GIS tools afterwards. So it takes a little bit more work, but a lot of times you can edit the data before you put it in, rather than having to go through a whole bunch of more work later once you've already put the data in to edit it. So there's all sorts of data here. So there's temperature data through the Mesonet. There's also precipitation data through that. There's tornado, hail, and damaging winds and severe weather sets. There's elevation data and aerial maps, which can be very useful when you're trying to show areas. The Kentucky Geo Portal is a big one because that has a ton of information. If you look something up on it, odds are you will find some sort of data on it in there, and all of that is free. I do have one thing, the Kentucky shapefiles. Some of the shapefiles on the site are free, others must be paid for. You can also get data when you have ArcGIS online. It comes with a whole bunch of data through what they call the Living Atlas. So they provide you with data that they are constantly updating that you can look at and use if need be. So in some cases, you are going to use data like this that you find online, and you're just going to edit it for your project to pick out the information that you need. Other times you're going to come up and you're going to have to find your own data, which can also be done through, there are ArcGIS apps that you can use to collect data, and you can get the longitude and latitude and the degrees and all the information that you need that way. Whether you want your own data or someone else's data really depends on the project that you're doing. If you're doing a project that involves a lot of information, a large area, or it takes place over a larger amount of time, odds are it's going to be easiest to go through and find already out there data sources that you can edit to just look at the information that you want. On the other hand, if you're doing a project that's very specific and you just want a small data set, not much to it, small area, sometimes it's easier to collect your own data. And in that case, a lot of times there isn't any data that you can find out there. You have to create your own, because the other data sets, you either have to pay and you don't want to, or there is no data that has been collected on that before, though that's not very common. So a lot of times you actually use a mixture of both, data that you've collected and data that other people have collected and you have edited in a lot of cases.
A project that I did, but this was a while ago, there actually might be data for it now. I did a project where I wanted to see how the interstate system affected businesses on the US highway. And I did a case study of I-65 and 31W between Bowling Green, Kentucky and Elizabethtown. I did have to go out and collect my own data. I drove up and down the road looking for old motels that were either still in business or that had changed to storage or small apartments. I also looked for circle driveways, because circle driveways were an indicator that there was probably a hotel there. I also went to the courthouses and did deed searches. So it did take a while. I'm not sure that I found every hotel that was on 31W, but I did collect my own data for that. And now with so many different planning commissions and county offices using GIS, it might be a lot easier to do the project now 20 years later with somebody else's data than collecting my own. All right. We know that students in a school without geography instruction can still access the ArcGIS online bundle as long as all they have to do is find a teacher that's interested. Like I said, school librarians or media teachers would be good. But Grace, what other types of skills do you think students should sharpen or practice or learn before they start working with GIS?
You really need to know some basic geography concepts, such as the cardinal directions, north, south, east, and west, latitude and longitude, and degrees, and how to use degrees, because there's different types. There's degrees, minutes, seconds, and then there's decimal degrees. And in GIS, you have to use decimal degrees, which means sometimes you have to translate because you can only find things in decimal, in degrees, minutes, seconds. So you need to know some basic geography concepts. A lot of them can be found, and there's a lot of information that can help you get those geography concepts through our GIS in the classroom pages, through the resources, the data sources, and the tutorials that we have. That's a great way to get started for this information. For ArcGIS Online, as I said before, there's also all sorts of lessons that you can do that will give you the basics. But yeah, as long as you have those basic geographical concepts, the rest will come as you're working. You will learn a lot as you start going through the process of learning how to use the GIS website and the data and the software.
Do you think that, do students have to have a basic understanding of data and statistics, or do you think that's something that they would understand as they used more of the data?
That will come as they use more of the data. There are tools within the data that for ArcGIS Online, you can use different tools for analysis. And some of them, they describe what they do. So they are statistical tools or they are analytical tools that will help you learn more about that. It can be helpful if you're going really in depth to have more of a background in that, so you know what it's doing and you know why it's doing it. But it will give you a basic description within the tool that's being run as to what's going on.
Okay, that sounds good. We did have another question for the participants, and it's related to some of the things that they've learned about in school. We just wanted to ask the participants, and you can unmute yourself and join us, or you could throw some comments in the chat. But we wanted everybody to think about the classes that they have taken and the lessons that they have learned in some of their classes in school, and think about which classes you have been in that might be best to use a GIS project. It could be a lot of social studies stuff could be used that way, but there are other science classes, depending on what level of science you're in. Maybe not microbiology, but macrobiology that talks about biodiversity and things like that. So can anybody think of any classes that you've already taken where you could have made a map about the topics that you're looking at?
For another example, in one of my classes, we looked at pH levels of soil, and then we mapped out the different pH levels so that we could see where should fertilizer be added, what should be added here, why are these plants growing better than these plants? So we mapped out the fields with the pH levels.
Yeah, there are a lot of history examples. I noticed somebody posted that in the chat. There are a lot of history examples, but we are finding more and more science related story maps. If you go into our story map gallery, there's one about the Mammoth Cave Biosphere Reserve. There's another one about karst hydrology, the movement of water through caves. But yeah, there are lots of history examples. Our story map gallery, we try to keep things in our story map gallery that are specific to Kentucky, but you could probably Google it and find some that are not specific to Kentucky. So the recycling and plastics one was one that somebody did for KGA for a few years ago. The Earth Day focus was on plastic, reducing plastics. So we had a student that worked the practicum in the past do a whole project on recycling plastics in Kentucky. The next one is the ArcGIS online competition for US and high school and middle school students, and that's a story map about the competition. I really like this Kentucky before and after because you can actually move the little circle around on the map and it shows you what it looks like now and what it would have looked like in the past. Oh, there's the one about karst groundwater is right there. So that's about the movement of water, and it actually connected that movement of water and water pollution to some of the communities that rely on well water. And then the one right before it is about the biosphere region. So if you want to learn more about Mammoth Caves biosphere region, you can look at that one. Okay, so lastly, before we go to any general questions, Grace, can you just remind us of some of the important resources that we have for the students?
Yes, so one of the bigger resources that we have is we do have that link to the Esri ArcGIS school license so that people can get the ArcGIS license and they can use ArcGIS with their school for free. We also have the KGA resources, so the story map gallery, the data, our geographers training guides, the Esri and other training modules for GIS that we've come up with. I think we also have some lessons plans and classroom tools for people to use if they want that are all related to mapping our GIS, if they would like to use those. And then we have, as we said, we are the state group for the ArcGIS online competition for middle school and high schools and other geographic resources such as that. So all of those projects will go through us, and then after they go through us and they are judged by a group of judges, some of those projects will go and compete on the national level, which those winners actually just came out yesterday. But you can look and you can find all sorts of very cool projects that people, middle schoolers and high schoolers, have done. But yes, we have a lot of geographical information. So the tutorials, the license, as I said, all sorts of things on our website to be used by anyone who wants to. So a very good way to make sure that you stay up with what we're doing and new opportunities is if you go and join us. It's completely free and you will get a newsletter that will keep you up to date on different information that we find, different projects that we're running. We're going to be having in February a webinar series, I believe, about different geographical topics and GIS topics. So you can get all sorts of things through this and it's completely free.
Yes, we tried to plan the webinar series to go along with the timeline of the GIS competition because the GIS competition takes place in the spring. We advertise that starting in the fall in some of our newsletters. Our newsletters only go out during our college school year, so September to April. May is basically finals week for us. The first 2 weeks of May are the week before finals and finals, so we usually don't send stuff out that week. We also do have an email that's posted on the website if anybody just had any questions or needed anything. Mostly that is monitored during the school year, not as much in the summer when we are off. So did anybody have any questions for Grace about her projects or any questions about the KGA in general?
I had a quick question about the Esri license. Can the students just go directly and access that and download ArcPro and use it directly, or is it a little more drawn out?
It has to be requested for the school. It has to be requested through a teacher at the school. But it's all the online stuff. So if they have a laptop and the school sets it up, the students should be able to access it through their laptop without being on campus or at the school. But the one that they have for free, the bundle is for schools. But they just have to find a teacher that would be interested to help them sign up.
Thank you.
It would be nice if students could do it themselves, but I don't think they have that for students themselves yet. If you want it individually, I think you have to pay for it. So it's best to go through a teacher, or even another thing that a student could do is maybe if there's not a teacher that's interested, there might be an information technology or a club. I think STLP is a group. I think that student technology leadership program, if there's that at their school, that might be a good option. There's some other programs. Even an agriculture teacher might be interested in doing it, because GIS is used a lot in agriculture now to look at both the weather and the soils and everything together. So they could ask any teacher. It just has to be somebody that would be interested in monitoring it.
Well, anybody that wants to work on some geospatial projects, if this is an issue for you at your school, let me know, and we'll start, we'll start finding allies and get this done. This is often a bottleneck. So in most of the events that we have, the very next show, we got to talk about QGIS, just so everybody can get up and running with some software. But Esri, there's just no substitute for the vast array of products that they have, and StoryMap is just the single greatest thing ever made. So yeah, really appreciate you sharing those.
That actually brings up a good question, because if students are homeschooled and they wanted to do it, from what I understand, it has to be associated with the school. So that's something I'm going to look into to see. I will contact the education person at Esri and ask them if there's if our organization could host some students ourselves. I'm not sure if they will say yes to that, because from what I understand, it's all done through the schools now. But I'm gonna write that down and look into that.
If anybody has any questions for Dr. Brown or for Miss Grace, please unmute yourself, or feel free to use the chat, or you can private chat me if you're nervous about exposing your thoughts or questions.
I am not a doctor. I only have a master's. I didn't catch that on the program. I just want to mention I have a master's instead of a doctorate.
Well, if there are no questions, just let me say once again, thank you both for being here. We really like to hear from the professionals, and certainly from former students or quasi students, making that transition into the professional world. So we really appreciate you coming on to share. Did you already mention, I had to jump off for a bit, but did you share briefly kind of what your story was about how you maybe jumped from high school and then landing, I guess, in the geography department? Did you happen to cover that, or would you mind covering that?
Grace?
Yeah,
Grace. Are you talking to Grace? Yeah.
Yeah, Grace. Did you study geography as an undergraduate? Was that your major?
I am currently an undergraduate, so yes, that is my major. I am a geography major with a focus in environmental science, and then I have a certificate in geographic information systems, or GIS, and then I'm also working on a certificate in emergency science and disaster management. So I got started, it was actually a bit of a happenstance. I had signed up for all my classes for my very first semester, and then I got an email in the middle of my summer before starting my very first semester about how one of my classes was no longer going to happen. So they had put me in a GIS class for ArcGIS Online, and whether or not I was okay with that. I had no clue what that was, but I was like, I'll give it a shot. And I walked into that class the first day. It was my second ever college class, and I loved it from the get-go. It was so much fun. I learned so much by doing it that I just couldn't get enough of it, which is why I'm now doing the certificate in it.
So what about knowing that geography was the major for you? So like maybe when you're in 9th, 10th, 11th grade, did you have some other aspiration, going to be a surgeon or something, and then you later find yourself in geography?
For me, it's a lot about the environmental science. When I was in 7th grade, I joined my school's energy club. So we work with the NEED National Energy Education Development Program, and then the Kentucky Green and Healthy Schools program. And we got to do so many projects helping people. So we got to create a community garden. I helped create a nature story walk for the community. We ran recycling programs and all sorts of community programs. We did experiments with fourth graders to get them excited in science. And I love doing the environmental education stuff and to learn more about the environment. So that's really where my focus started. And that led me to the geography department here at WKU.
Can you tell me a little more about the community garden? You said you put one of those together before?
Yes, it was actually, I wrote the grant for it when I was in 9th grade through the Disney Friends for Change grant. So it was me and another student. So we created a community garden in our courtyard of our school. So we grew, well, we mostly grew squash and pumpkins because those go everywhere and they're very easy. But we grew corn for some time. And it was really something that once a week, a group of students would go up. And then in the summer, I took my younger siblings and maybe a couple of their friends up, and we would work the garden. So we would weed it, and anything that we grew, we would get to take that home and we could share it or we could give it to other students. Right now, it is currently being turned into a garden with natural plants for butterflies and other native insects. And then I believe the plan is also to put an outdoor classroom around it to get all sorts of people outside and to also use the garden to help get natural plants and native plants and animals back into the area.
Let me just say that we would love to have you back sometime in the near future to talk about that more. One of the groups that are on here, Mr. Cole's group, Jeffrey Cole's group, he's in Lexington and he has a bunch of students. They are at a place called Thelma's Garden Academy or something like that. Half of their summer experience is connected to agriculture, and they have some big plans for kind of scaling up the things that they do and then adding these various entrepreneurial aspects to it and having it kind of being a community facing thing. And we're just really happy to talk with folks that have any experience in kind of doing that in that kind of volunteer / community kind of area. So I'm really glad that you brought that up, and I'll be bugging you very soon to try to get you to come back and share more about that with us. Last call for questions. Anybody, just unmute and blurt it out. We'll check the chat, and if there's none, thank you very much for being here, and feel free to close it out however you like.
Well, thank you for having us. I hope some of you join the KGA and are interested in possibly joining the competition in the spring. This coming year will be our second time hosting the competition, the ArcGIS online competition for middle and high schools. We would love to have more entries than we did this past year. I think COVID kind of dropped some of the teacher participation, but hopefully next year we'll have more involvement from students. So especially if any of the students are interested, if a student is interested and you ask a teacher, most teachers will respond delightedly that you are interested in doing something that they can help you with. So thank you all for.
Hello, this is Jeff Coles with the Academy at Tea Garden. And we just want to thank you. You have encouraged us in terms of what is expected on the college level, some of the surprises, as well as some of the planned out things. And we just wanted to let you know that we will be looking forward to information regarding GIS competitions in the fall, I guess. Thank you very much.
All right, thank you.
Yep.
Thank you.
Thank you very much. Have a great day. Thank you again for being here. Can't say it enough. Thank you.
Hey, Jeremy, one last quick question, if I might.
Sure, go ahead, sir.
Yeah, so I work with some schools in Eastern Kentucky, and so I can see lots of applications for geographic interest, I'll just call it that broad umbrella. should I, Grace, or what's the best way to do it?
What's the best way for students way out in East Kentucky to be connected? One of the biggest issues for them out there is that there's so much space between them. And we even have 2 schools that literally the students can't get internet access. So it's very often, it's a second conversation to have immediately where take this and that, and then internet connectivity, just kind of stops the show right in the beginning. So I believe his question may be getting at that, because he's having a lot of conversations with school officials out there. Everybody wants to do STEM and everybody wants to do tech and web this and that, and last mile is still the #1 problem. So his question was probably getting to how can we get a little further on that? Perhaps. I know there's offline kind of options that go along with this. So with a little more prep work, obviously, but what else can we might think about on that?
I live out in the county, and I have struggled with that. Like I said, I came into the office just to be able to have the internet, and then my computer went off on me because I hadn't been in here in a while, I guess. Not having any service at all, that's part of the digital divide, and that is an issue for the rural areas in Kentucky. Where I live, for 4 years, we had to hotspot our phones because there was no other way for us to get internet. And we just picked a service that had, where everything was all inclusive. I know that's a little bit different for school systems to not have service. I'd like to say I hope that they get it soon so that they can participate. But that is a digital divide issue that I don't really have a good answer for regarding using some of the online GIS things. But that is another question that I can put towards ask my Charlie at Esri about that, because there might be something they can download and work with when they don't have it, but they'd probably have to have access to be able to download it in the first place.
So,
but I'm going to make a note of it because I'm going to email him after we get done today.
So the question kind of had 2 parts, and the first part certainly was internet access and the digital divide, and there are issues around that. But the second part of that question is, how do we get kids engaged? And I don't know if you can even answer this, but how can we get kids engaged and interested in geographic stuff, GIS stuff, and who can be a liaison for that kind of thing? And I know we can reach out to Kentucky State University, and we've done some of that already. But what is a good way if a student just pops up one day and says, "Hey, I'm interested in geography"? Do they? I'm being, not very funny here, but hey, I'll just call Gracie. She'll help me out. So what are good ways for students and or teachers or staff or whatever to connect with folks sort of in the industry?
I'm going to answer that, and then maybe Grace could follow up with the student point of view. But I teach a lot of general education classes. I only teach 1 for majors. So I have students in there that may or may not be interested in geography or environmental science. I have tried 2 different routes or 2 different tactics. One is a geo-inquiry tactic where if I have time, the students come up with their own project. The issue that I have when I have students come up with their own project and brainstorm their own project is I find that a lot of students spend the most time deciding what project to do and then not as much time on the actual project. I've done class projects when I've had honor students in gen ed, and that's gone a little faster because I give them a timeline where they as a group have to decide what kind of project they want to do. But when I don't have a lot of time, I usually pick the topic ahead of time, and I try to pick something that would appeal to all students that are involved. So for example, in my seminar series class, my project for GIS, and that class is stormwater runoff, because that is something that the science students would like if they're interested in water. If they're interested in weather, there's a weather aspect.
If they're interested in the sustainability part and how stormwater affects people in different parts of town, then it really hits a variety of people. So picking a broader topic that they can narrow down on is sometimes helpful. But like I said, I've tried both where they try to come up with their own project, and that the challenging thing for that is that they sometimes take a long time to decide. But based on your question, I think one of the things that we could do at the KGA is we have modules, we have training modules about geography. We could probably develop some sort of program that they could move through and get a certificate at the end. I think the certificate itself might be, go ahead.
Yeah, I think that would be excellent because it gives them some sense of accomplishment. So I really like that idea. And the other thing is, what about a geography roadshow, and maybe pick sort of 5 counties, in my case, it'd be 5 counties in Eastern Kentucky, and to kind of put on an entertaining, you know, I'm not talking about jugglers and magic acts, but entertaining in the sense of here's what, you know, GIs can bring to the table, and do some stuff that shows what happens in the mountains of Eastern Kentucky as an example, or what's happening in their county. You know, make it real to them, but in a stuff they didn't know about. So a roadshow, geography roadshow.
I think that's a good idea. That is something that could be done virtually like this. For us, that's since we no longer have our grant, most of our stuff is now virtual. We're trying to move more towards training modules and everything being online, because without the grant, we don't have money for people to come to us or for us to go to them like we used to. But I like the Geography Roadshow. And we do have a newsletter. So I'm wondering if one of the things that we usually do is we highlight stuff in our newsletter and then put it on our website. So maybe that's a way that we could do it through, I'm thinking while I'm talking. I'm going to stop thinking, just say, that's a really good idea. I'm going to see what I can do. And that might be something that we could do with some other university faculty from some different colleges.
Yes.
Through the state school system.
We'd be happy to help in any way, connect you to the guy talking, David. He's involved in a lot of various things that we do, and he's very included in most of the outreach stuff that we do. So he's very in touch with the farmers and the foresters and the entrepreneurs and the ag space and all that.
Okay.
Well, I appreciate that extra. Thank you very much both for being here today. Folks, that brings us to the end of our AM session for today. We're going to start back at 1 p.m. With Ariel Weaver. Reminder that the PM sessions, they are pre-recorded, but I'll be on here at 1 o'clock getting started, and we'll move forward just like that. So thank you all. Have a good lunch, and I'll see you back at 1 if you can be free. Thanks a lot.
Thank you.
Thank you.